take a look at another example that involves parallel and perpendicular lines. And in this time, we're going to have to prove, using a two-column proof, two lines are parallel. But before we do that, I want to review with you two important theorems. One of the theorem is called perpendicular transversal theorem, a very, very important theorem. It says that in a plane, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line. Once more, it's called the perpendicular transversal theorem. If you have a transversal, here's our transversal, and if it is perpendicular, notice the perpendicular symbol, if this transversal is perpendicular to one of two parallel lines, it's perpendicular here, these two lines are parallel, then we can say that it is perpendicular, this transversal is perpendicular to the other line. In other words, line Q, which is this line, is perpendicular to line P. So we have the transversal perpendicular to line P. I'm going to go ahead and put a symbol here. Okay, that's what this theorem is saying. Let's look at another one. In this theorem, it's saying if you have two coplanar lines that are perpendicular to the same line, then the two lines are parallel to each other. Once more, if two coplanar lines are perpendicular to the same line, you see these two lines right here, R and S. If these two coplanar lines are perpendicular to the same line, which is line T, what can we say? That these two lines are parallel. Another way, a short way of saying that, two lines perpendicular to the same line implies that these two lines are parallel. Okay? Knowing that, let's see if we can go through this two-column proof. This is what we're given. In this two-column proof, we are given that AB line is parallel to DC. Here's AB. AB, sorry about that, is parallel to DC. So I'm going to use an arrow to mark this line parallel to DC. Okay. We're also given that AB line, which is here, is perpendicular to line CB. And that's already been indicated for you. This line is perpendicular, so you have four right angles being formed right here. We're also given that AD line, AD, is perpendicular to DC, right here. What are we trying to prove? We're trying to prove that line AD, which is here, the green, is parallel to BC. Okay? Alrighty. Let's get started. One of the very first things in a proof is I always like to go back and revisit the given, and it's usually the first statement in the proof. AB is parallel to DC, that's given. AB is perpendicular to line CB, that's given also. Now, what's our next step? Our next statement, we can say that because of the perpendicular transversal theorem, line DC is perpendicular to BC. Line DC is perpendicular to line BC because of the perpendicular transversal theorem. What's our next statement? We were also given up here that line AD was perpendicular to line DC. Look at this. What do we have? line DC perpendicular to BC line AD perpendicular to line DC. Do you see something? Yes. Two lines perpendicular to the same line, we can say that what? Line AD is what? Parallel to BC, to line BC. Because if you have two lines perpendicular to the same line, then those two lines are parallel. And guess what? That's what we were trying to prove.